Okay, so these problems we would have done in class. So Unit 6, Section 2. And this is the example from the notes packet. Determine the equation of a circle that passes through the given point and has y-intercepts. Okay, now, if we were to think about a sketch of this, okay, y-intercept of 11, y-intercept of negative 13, and it goes through the point negative 7, comma 4. So none of this information tells us that the endpoints are a diameter. Okay, if the endpoints were a diameter, then we could find the distance and determine the radius from that. But what we do know, and I'm not even going to attempt to... Okay. So, circles, fairly pathetic looking. What we do know about a definition of a circle, from the center to any point on the circle, I know that those are equidistant. And what are those called? Those are our radii. Okay, so from the center to any point on the circle, those lengths are equidistant. So what we can do with this is we're going to take two of the points that are given, and we're going to plug that into our general form of the equation of a circle. So y-intercept of 11, that would correspond to the ordered pair 0, 11. This would correspond to the ordered pair 0, negative 13. So I'm going to plug that in. So I have not x. So I have x minus h quantity squared plus y minus k quantity squared. And if that's equal to an r squared, then so too will the point 0, negative 13 when I plug it in. So I'm going to set that equal to the circle when I plug in my other y-intercept of 0, negative 13. Okay, because again, if my radii are equivalent by definition of a circle, then I'm saying r squared must be equivalent as well. Okay, so expanding this will give me h squared. Square the first term, double the product, square the last term. On the right-hand side, h squared, square the first term, double the product of the two terms, square the last term. Okay, so now from here, when I go to solve, a couple things cancel. K squareds on both sides are the same, they cancel. H squareds on both sides are the same, so they cancel as well. So now I have one equation, one unknown. So I'm going to subtract 26k and then subtract 121 from both sides of the equal sign. Okay, so that gives me negative 48k equals 169 minus 121 equals positive 48. So I have k is equal to negative 1. All right, so now if I know that k is equal to negative 1, I'm going to resubstitute k is equal to negative 1 with my point negative 7, negative 4, and now only one of my y-intercepts.
Are you doing all this?
Shh. So I take this and I have x minus h quantity squared plus y minus k. We just found k to be negative 1. Quantity squared.
Quantity squared.
This is I'm going to run out of room here. So let me just move these up. So I had negative 48k equals 48. All right, and then I'm going to set that equal to, I'm plugging in this y-intercept, so x minus h quantity squared plus y minus k quantity squared. Okay, so Jameson, move back.
Why do you need a top?
Okay, so square the first, double the product, square the last term. 4 plus 1 is 5. 5 squared gives me 25. On the right-hand side, I have h squared. 11 plus 1 gives me 12. So 12 squared is 144. So now I notice my h squareds again cancel. And I'll have 14h plus 74 equals 144. Subtracting 74 from both sides, I get 14h equals 70. So now the x-coordinate of my center is positive 5. Okay, so we're almost there. X minus h, quantity squared, plus y minus k, quantity squared, equals r squared. So the last thing that we have to do is find the value of r squared. We have 3 ordered pairs here. Doesn't matter which one we plug in, either one will give me the right answer. So now I'll take this point. So I have x minus 5 squared, negative 13 plus 1 squared equals r squared. 25 plus 144 is equal to r squared. 169 equals r squared. Now all we want is the equation of the circle, so I don't even need to solve for r here. Plugging in the final piece of information equals 169. And that's my answer. Okay. So I don't need that. All right, now this is from page 222. This would have been assigned from for homework the first day. You have a circle that's tangent to the x-axis at 4, 0, and it has the given y-intercepts. Okay, a tangent line. So a tangent line is a line that intersects a function in exactly one point. So if I think about what this is graphically, 1, 2, 3, 4, if that's my point of tangency, then that means it's the circle has to intersect right at that point. Okay, so if this is a point of tangency, then really that gives me a lot of important information. And what that means is it's going to be an end point of a given radius. So if I have the point 4, 0 as a point of tangency, then I know 4 has to be the x-coordinate of the center of my circle. Okay, because that's the only way that I could maintain that that point 4, 0 would be tangent to the circle. So if that's the end point of a radius, then again, using the technique from the last problem, I'm going to plug in my ordered pairs, 0, negative 2, and 0, negative 8. And I know that these are 2 points on the circle, so each of those radii then have to be equal. X minus h, quantity squared, plus y minus k squared equals x minus h squared plus y minus k squared. All right, again, squaring the binomial, square the first, double the product, square the last. This will equal h squared. Square the first, double the product, square the last. So now looking at both sides of the equation, h squareds cancel, k squareds cancel, and I get 4 plus 2k equals 64 plus 6k. Subtracting 64, subtracting 2k. Hold on. Oh, this is 4k. Double the product. So I get 12k, and I get negative 5 is the y-coordinate of my center. So now I have my y-coordinate of my center to be negative 5, and furthermore, I know what my radius is here. So if I'm saying that the point of tangency is the endpoint of a radius, and I know what my center is, then my radius has to be equal to 5 units. So putting that information together, x minus 4 squared plus y plus 5 squared has to equal 25 because my radius is equal to 5. So there's the equation of the circle. All right, last example. This was number 18. Nope. All right, sorry about that. Forgot to change the question. All right, so when you're given an equation, then we need to complete the square to be able to find center and radius. So I'm going to collect my x's, collect my y's, and there's no constant term to move over. Now, when we talked about completing the square at the beginning of the year, the one condition was that the lead coefficient had to equal 1. Nope. Well, the lead coefficient to both the squared, x squared, and the y squared term is 2. So the first thing that I'm going to have to do is to get rid of that. So I'm going to divide every single piece of both sides of the equation by 2. And that'll give me x squared minus 5/2 x plus some value to complete the square, plus y squared plus 1/2 y plus some value to complete the square is equal to 0. Okay, I know we're dealing with fractions, but you'll survive. So now to complete the square, I have to take half of negative 5/2. So half would give me a negative 5/4. When I square that, I would add 25/16 to complete the square on the x. For the y, half of a half is a 1/4. When I square 1/4, I get 1/16. To maintain balance, I have to add 25/16 and 1/16 to the right-hand side of the equation as well. So remember, the whole reason that we complete the square is so that we can write each expression in factored form. So I have x minus 5/4 quantity squared plus y plus 1/4 quantity squared. And now when I add these together, that gives me 26/16, which I'll reduce to 13/8. Okay. It is not coincidental that these numbers here are exactly the values we use to complete the square. 1/4, positive 1/4. Okay. Or you can think of it as square root of x squared is x. The sign of the middle term matches the sign of the expression and the square root of the term that you introduced. Okay, either way, in order for you to be able to recognize how these pieces fit in. So now to answer the question, the center is 5/4, comma, negative 1/4 with a radius of the square root of 13/8. And you can leave it like that. There's no need to rationalize the denominator or simplify that square root of 8. So please see Teams for the rest of your assignment.